Okay, so have you ever stopped to think about what makes your smart fridge actually smart?
Or like, how come cars can practically drive themselves now?
It's wild. We're doing a deep dive on embedded systems software development today, mostly because it seems like this is something you're thinking about for your career.
And honestly, after looking through this RoleCatcher thing you sent,
Hmm.
kind of want to be an embedded systems developer now too.
Right. It's so cool. We're talking the core tech behind pretty much every device that interacts with the real world in a smart way.
And get this, RoleCatcher says that this whole field is about to explode. Like, it's not just growing. We're talking 22% projected growth over the next 10 years.
Yeah, that's insane. 22%. Okay, so obviously it's a good time to be an embedded systems developer, but what are they actually doing every day? It sounds super intense.
It's pretty full on. Imagine you're building a heart rate monitor. It's not just about reading your pulse rate, but it also has to react to changes instantly. And then send that data somewhere and maybe sound an alarm if something's wrong. Embedded system developers are the ones who make all that happen. They write code, design the system, the whole thing.
So it's not just coding, but understanding how what you're writing interacts with the actual hardware.
Hmm.
And in these situations, it could be life or death. That's a lot of pressure.
You're telling me? And actually, speaking of pressure, RoleCatcher doesn't sugarcoat the challenges. Long hours, crazy stress, having to constantly learn new tech. It's not exactly a 9-to-5 job.
No, but I feel like for the right person, that's got to sound kind of awesome, right? Like you're on the cutting edge of tech, solving these complex problems. I can definitely see the appeal. So let's say you're totally sold. What does the path to becoming an embedded systems developer even look like?
Well, RoleCatcher's all about that bachelor's degree to start.
Yeah.
Computer science, software engineering, that kind of thing. But, and this is important, they really emphasize practical experience, internships, open source projects, even if you're just messing around with your own embedded systems at home.
I love that. They want to see that you've actually gotten your hands dirty. It's not just theory. You need to know how to build stuff.
Totally. And networking is huge for them too. Conferences, professional groups, those are how you meet people in the industry and find out about cool opportunities.
Okay, so you've got the degree, you're building real projects, you're out there networking. What about the actual skills? The RoleCatcher guide had a lot listed there. What are some of the absolute must-haves for someone who's just starting out?
Well, they're big on programming languages like C and C++ and R, but it's not just about knowing the code. You have to understand how it works on these devices. Every single line you write affects how well it performs. They also mentioned being comfortable with real-time operating systems, or RTOS.
Okay, so break that down for me. What's so special about RTOS?
Okay, so remember that heart rate monitor we were talking about? RTOS is what guarantees that the software reacts in real time, like instantly. No delays. It has to be predictable and super fast. It's a big deal for things like medical devices, industrial control systems, stuff like that.
So it's not just about the code itself, it's about understanding how that code works with what the system needs. It's like you're building the brain and the nervous system of these devices all at once. That's insane.
Right. It's a whole other level. And the cool thing is, RoleCatcher doesn't just leave you hanging at entry level. They lay out your whole career path, from junior developer all the way up to principal developer, almost like a roadmap.
Okay, so let's talk about those career paths. What's the usual progression for an embedded systems developer?
So usually you start as a junior developer, helping out with basic stuff, writing some code, debugging. You're getting a feel for how things work, with more experienced developers showing you the ropes. Think of it like an apprenticeship in the world of embedded systems.
So you're learning the basics, mastering the fundamentals.
No.
Then what? What's the next step up?
Once you've got some experience and you're feeling more confident, you usually become a full-on embedded systems developer. At this level, you're taking on more responsibility, designing and making software solutions, doing system analysis, troubleshooting problems. Basically, you're becoming a real problem solver.
So you're not just writing code, you're looking at the bigger picture. What kind of impact can you have at that level?
It can be pretty huge. You're working on real-world projects, collaborating with engineers and designers to bring those projects to life. And as you keep learning and getting better, you might even move into a leadership role.
Ah, so that's where the senior embedded systems developer comes in.
Exactly. As a senior developer, you're not just a tech expert, you're also guiding and mentoring junior developers, making sure everyone's following best practices. Basically, you're shaping how the projects are done.
So you're a leader, a mentor, and a tech whiz all in one. That's impressive. But there's still one more level, right? The peak of the embedded systems mountain.
You're kind of the principal embedded system software developer.
Okay, paint me a picture. What does a day look like for someone at that level?
Well, you're not really doing much day-to-day coding at that point, although you're definitely still in the loop. They're the visionaries, the big picture thinkers, the ones leading innovation, defining goals, working with stakeholders, basically shaping the entire future of embedded systems.
Wow, that's a pretty amazing career path. You start by learning the ropes, then you're leading projects, mentoring others, and eventually you're shaping the future of technology.
And RoleCatcher lays it all out there. They even have these example profiles of people at different stages so you can see where you might fit in. It's really helpful for picturing what's possible.
It's like having your own personal career mentor. But what about people who are coming from a different background? Like maybe they don't have a traditional computer science degree. Can their skills translate to a career in embedded systems?
That's a great question, and it's something RoleCatcher actually talks about directly. They have this whole section on transferable skills.
All right, tell me more. What kind of skills are we talking about?
Well, if you've worked as an ICT application developer, an application engineer, an ICT systems developer, or even just a software developer in general, a lot of those skills could be really useful in the world of embedded systems.
So it's not about starting over completely. It's about using what you already know. What kind of overlap are we talking about? Give me some specifics.
Think about stuff like analyzing software specs, making flowcharts, debugging software, developing prototypes, even just understanding technical documents. These are all important for both regular software development and embedded systems.
That's good to know. It gives people options if they're thinking about switching careers. They don't have to start from zero.
Exactly. And it's not just about those main development skills. Things like being able to adapt to new technology, analyzing customer feedback, even UI design. Those can be transferred too.
So it's really about taking what you already know and applying it to this new area. What you're saying is don't underestimate your past experience. It could be way more relevant than you think.
For sure. In fact, RoleCatcher actually encourages you to look at their list of transferable skills and see for yourself. You might be surprised by how much you already bring to the table.
This is so helpful. I'm starting to feel like I could be an embedded systems expert
Well,
myself.
too. It's kind of contagious, right?
We've covered a lot here. What the demand is like, what you do every day, career paths, those transferable skills. What's the main thing you want someone to remember if they're really considering this as a career?
I think the biggest thing is to be passionate about tech and be
Right.
really interested in how things work at their core.
You have to love the challenge of figuring out how to make software and hardware work together perfectly.
Exactly. And don't be afraid to experiment and build things.
Yeah, experiment, build stuff, break stuff, learn from your mistakes.
That's the only way to become a real expert in this field.
It sounds intense, but also incredibly rewarding. Speaking of rewards.
You mean the money, right?
Right.
Let's be real. That's a big part of it for most people.
You read my mind. Luckily, RoleCatcher gave us some really detailed salary info, so let's get into it. What can someone expect to earn at different points in their embedded systems career?
Okay, get ready for some big numbers. According to RoleCatcher, the average starting salary for a junior embedded system software developer is about $65,000 a year.
Not bad at all for a starting point, but obviously that's just the beginning, right?
Oh, yeah, it gets really interesting from here. Once you go from junior to a full-fledged embedded systems developer, you're looking at an average of $95,000 per year.
Wow, that's a big jump. Why such a big increase?
It's a bunch of things. By that point, you've probably gotten really good at those core skills, programming, architecture, RTOS, and you're taking on more responsibility for projects. You're not just following orders anymore. You're actually designing things and making decisions.
So you're more valuable to the company, which means you get paid more. Makes sense. But it doesn't stop there. What about the people who really climb the ladder and become senior embedded system software developers? What can they expect to make?
Now we're talking serious money. At the senior level, the average salary jumps to around $130,000 per year.
Okay, now we're talking. That's amazing. But we can't forget the top of the mountain. The principal embedded systems software developer. What's the compensation like at that level?
Well, you can imagine getting to principal level means you're at the top of your game, and your salary shows it. The average for a principal embedded system software developer is around $170,000 a year.
Wow, that's incredible. And to think you might have started out just playing around with circuits in your basement.
Exactly. This goes to show how much these skills are in demand. and how much companies are willing to pay for experienced embedded systems developers.
It's a really inspiring career path, both in terms of the work itself and how much you can earn. But before we move on, there's one more important thing I want to bring up.
You're thinking about the gender pay gap, right?
You know it. It's a big problem in a lot of industries, especially in tech.
For sure. And while RoleCatcher doesn't have specific numbers on the gender pay gap in embedded systems,
Mm.
it's important to acknowledge that it's a real issue that needs to be addressed.
It's about creating a tech industry that's more fair and inclusive for everyone.
Exactly. And that means being aware of potential biases, pushing for pay transparency, and promoting diversity at all levels.
Well said. Okay, now that we've talked about the money stuff, let's move on to our last segment. We'll get into the really exciting real-world uses of embedded systems and explore what the future holds for this field that's changing so quickly.
You know, it's easy to get lost in all the technical stuff. But what I really love about embedded systems is seeing them out in the world. We're talking about tech that's not just changing things, it's actually saving lives.
Okay, now you're speaking my language. Give me some examples. Where are embedded systems making the biggest difference?
Well, healthcare is a big one. Think about it. Pacemakers, insulin pumps, all that advanced imaging equipment, those are all running on embedded systems. They're making treatments less invasive, way more effective, and they're giving people a better quality of life.
It's crazy to think these tiny little computers are having such a huge impact on people, but it's not just healthcare, right?
No way. Look at cars now.
Yeah.
Modern cars are basically computers on wheels at this point. Embedded systems control pretty much everything. How well the engine runs, how much gas it uses, even safety features like anti-lock brakes, airbags, and those lane departure warnings that stop you from accidentally swerving out of your lane.
Oh, yeah. And we can't forget about self-driving cars. That tech blows my mind.
I know, right? And it's all thanks to these really advanced embedded systems. They process data from sensors super fast, making decisions in like milliseconds to navigate through traffic,
Oof.
avoid obstacles, and hopefully make driving safer for everyone. It's honestly a crazy accomplishment for engineers.
It's like we're living in a sci-fi movie. But it's not just life-saving medical devices and self-driving cars. Where else are we seeing embedded systems popping up?
Well, what about the Internet of Things, or IoT?
Ah, right. Everything's connected now. Phones, fridges, even our thermostats.
Exactly. And embedded systems are what make that connectivity happen. We're talking about smart homes that automatically adjust your lights and temperature, wearable fitness trackers that track your every move, industrial sensors that make factories run better. It's all powered by embedded systems.
So basically, if it can collect and send data and it interacts with the real world in a smart way, it probably has an embedded system inside. That's a huge range of stuff.
It really is. And as we get more and more reliant on all these connected devices, the need for good embedded systems developers is only going to keep growing. But we got to be real. This field has its downsides too.
True. The RoleCatcher guide didn't try to hide that. They talked about things like a lot of stress, working long hours, always having to learn new stuff. It's not a job for everyone, is it?
It's definitely not easy street, that's for sure. When you're working with embedded systems, you often have tight deadlines, not a lot of resources. And the pressure's on to deliver software that's reliable and works perfectly.
Right.
Because if it doesn't, the whole device could fail.
I bet there are times when you're stuck debugging a problem for days, just pulling your hair out, trying to figure out why one line of code isn't working.
Oh, totally. It can be so frustrating. But that's also kind of the exciting part, you know? It's like solving a puzzle. You have to get creative, and when you finally figure it out, it's the best feeling.
So how do you even keep up with all the changes happening in this field? What does RoleCatcher say about staying ahead of the curve?
Well, they're really big on continuous learning, which makes sense since things are always changing. They suggest going to industry conferences and workshops. That way you can beat other people in the field and hear about the latest and greatest stuff.
Right. They also mentioned joining those professional groups and being active in online forums and stuff. It's all about sharing knowledge, right?
Exactly. And don't forget about good old-fashioned self-learning, reading industry magazines and websites, playing around with new tools, taking online courses. Those are all super important for staying up to date in the fast-paced world of embedded systems.
It's like you're always a student, constantly learning new things.
That's what makes it so cool. There's always something new to learn, a new problem to solve. It never gets boring.
So we've talked about all the amazing ways embedded systems are being used and the challenges that come with it and how important it is to never stop learning. But let's get specific for a second. What are some must-have skills and things you need to know to be successful as an embedded systems developer? What does RoleCatcher say are the non-negotiables?
Well, the absolute most important thing is having a strong foundation in programming. And when I say strong, I mean really strong.
Right. We talked about C and C++ earlier, but it sounds like it's more than just knowing the language. It's about understanding how to write code that's efficient and reliable, especially for these devices that don't have a ton of power.
Exactly. It's a whole different game compared to regular software development, where you usually have way more processing power and memory to work with. With embedded systems, you have to pay attention to every little bit of memory, every single clock cycle. It's all about squeezing out the best performance and efficiency possible.
It sounds like you need a deep understanding of how the hardware and software work together.
You got it. And that brings us to another super important area, embedded systems architecture. You need to know about microcontrollers, memory management, input-output, all those communication protocols, basically all the pieces that make up these systems.
No, it's not just about the code itself. It's about understanding how that code talks to the actual physical parts of the system. It's like you need to be fluent in both the language of software and the language of hardware.
That's a perfect way to put it. And we can't forget about those real-time operating systems, or RTOS. Remember our heart rate monitor example. RTOS is what makes sure the software reacts instantly without any lag or delay.
Right. It's all about being predictable and lightning fast. It sounds like RTOS is crucial for any embedded system where timing is super important.
You got it. Knowing how to work with an RTOS, how to set it up, and how to write code that fits within its rules. That's a key skill for any embedded systems developer.
So, just to recap, we've got programming, embedded systems architecture, real-time operating systems, and a whole lot of coffee, I'm guessing. Anything else we should add to that list of must-have skills?
Well, besides all that tech stuff, RoleCatcher also says those soft skills are super important too.
Of course, we can't talk about any career these days without mentioning soft skills.
It's true. It's not enough to just be a coding genius. You have to be able to talk to people, work together on a team, and solve problems with other people.
Which makes sense, because even though it's super technical, you're rarely working alone as an embedded systems developer.
Right. Right. You're almost always part of a team, working with other engineers, designers, and stakeholders to make these projects a reality. And that's why being able to explain your ideas clearly, whether you're talking or writing, is so important.
So it's not just about the code, it's about explaining how you got there, documenting your work, and collaborating with others.
Exactly. And then there's problem solving, which is like the foundation of being an embedded systems developer. You're constantly running into new problems, fixing bugs, finding creative solutions, and often you have to do it all on a tight deadline.
So you need to be adaptable, resourceful, and able to think on your feet.
Exactly. And those are good skills to have in any job, not just embedded systems.
Okay, so to sum it all up, to be a successful embedded systems developer, you need a mix of serious technical chops and those crucial soft skills. You have to be well-rounded. Someone who can code and communicate, collaborate, and most importantly, solve problems. But what about someone who's thinking, this all sounds amazing, but I don't have a computer science degree. Is this even a possibility for me?
That's something a lot of people wonder about. And luckily, RoleCatcher talks about that directly. While a formal degree can be a big help, it's not the only way to become an embedded systems developer.
Okay, so what are some other ways someone could break into this field?
One option is to do a coding boot camp or a certification program that focuses specifically on embedded systems. These programs are usually shorter and more intense than a traditional degree, and they can teach you the practical stuff you need to know to get out there and start working right away.
They're like crash courses to get you job ready as fast as possible.
Exactly. And because they're often designed to meet the needs of specific companies and industries, they can be a really good way to get your foot in the door, even without that computer science background.
RoleCatcher also mentioned building up a portfolio of your own projects. How important is that, especially for people who don't have traditional work experience?
It can make a huge difference. Personal projects are a great way to show off your skills and your passion to potential employers. It proves that you're not all talk. You're actually out there building things, experimenting, and learning as you go.
So even without a fancy degree or years of experience, you can still show what you can do through the projects you choose to work on in your free time.
Exactly. And there are so many resources out there now to help you. Tutorials, open source projects, online communities. It's all about being resourceful, taking the initiative, and being hungry to learn and build new things.
And we can't forget about the power of networking.
For sure. Going to industry events, connecting with people online, reaching out to people who are already doing what you want to do. Those are all great ways to learn from others, find mentors, and maybe even get some job leads.
So even if you don't have a typical computer science background, there are still ways to get into this field. It's about being proactive, using what you know, and showing companies what you're passionate about and what you can do. But let's say you've done all that. You've got the skills, the experience, and you're ready to land your dream job as an embedded systems developer. Any tips for absolutely crushing that interview?
You're in luck because RoleCatcher has a whole section on getting ready for interviews. They really did think of everything.
Of course they did. They're like the embedded systems career gurus.
Yeah,
But besides what they have, are there any general things someone can do to make a good impression?
totally. First things first, research the company and the specific job you're applying for.
That seems obvious, but you'd be surprised how many people don't do it.
It's so important. You need to be able to show that you understand what the company does, where you'd fit in, and how you could help them.
So do your research, check out their website, read their blog, maybe even look at some of their projects on GitHub. It shows you're really interested and that you've put in the effort to prepare.
Exactly. The more you know about them, the better you can tailor your answers to what they're looking for. And speaking of preparation, practice your answers to common interview questions.
Right. RoleCatcher has a ton of practice questions, which is super helpful.
It's a great resource.
Yeah.
But even beyond those specific questions, think about your own experiences, your skills, your career goals, and figure out how they connect to the job.
They're not trying to trick you. They just want to see how you think, how you explain things, and whether you'd be a good fit for their team.
Absolutely.
Yeah.
And don't be afraid to ask good questions yourself.
That's a great point. It shows you're curious, you're paying attention, and you're thinking ahead.
Exactly. Turn the interview into a conversation. It should be a two-way street where you're both trying to figure out if it's the right fit. And finally, relax. I know it's easier said than done, but try to enjoy it.
Interviews can be nerve-wracking, but remember, they called you in for a reason. They saw something in you, something that matches what they're looking for.
So take a deep breath, be yourself, and let your passion for embedded systems show. Because at the end of the day, being excited about this field and genuinely interested in the work, that can be just as important as technical skills.
They want to see that you're not just there for any job. You're there because you're really into what they're doing and you want to be a part of it. But there's one more crucial part of getting ready for an interview, especially in a field like embedded systems.
You're right. We can't forget about showing off those awesome projects you've been working on. Be ready to talk about them in detail.
Right. We talked about how important it is to build a portfolio, but now it's time to really bring those projects to life during the interview.
Exactly. And I don't just mean listing them on your resume. Be ready to dive into the specifics, the problems you ran into, the solutions you came up with, what you learned along the way.
Because those projects show what you can actually do, especially if you don't have a ton of formal work experience.
Exactly. And don't be shy about getting technical. Show them your code. Walk them through your design choices. Let your passion for the project really shine through.
It's about telling your story as an embedded systems developer, even if you're just starting out.
Exactly. So to sum up those interview tips, research the company, practice your answers, be ready to talk about your projects, ask good questions, and most importantly, be yourself.
It's all about showcasing your skills, your experience, and how much you love the world of embedded systems. Now, I know we've covered a lot already, but I'm really curious to hear more about those real-world examples of embedded systems you were talking about. Can you give me some specific examples of projects that embedded systems developers are working on?
Oh, for sure. Get ready to be amazed because the possibilities are practically endless. We're talking about everything from...
Okay, so before we get totally off track talking about interview stuff, you were about to tell me about some crazy, cool, real-world embedded systems projects.
Oh, right.
Don't leave me hanging.
Okay, so get ready to have your mind blown because the stuff they're doing is insane. Imagine a world where traffic lights change based on how much traffic there actually is. No more waiting at a red light when there's not a single car coming the other way. That's embedded systems in smart cities.
Okay, that's pretty awesome, I'm not gonna lie. What else you got?
All right, how about this? Precision agriculture. They use sensors to track everything about the soil and the plants, like how much moisture there is, even how healthy the plants are, and they get all this data in real time. Then embedded systems take all that data and use it to figure out the best way to water the crops and how much fertilizer to use and when to use pesticides. So basically, it helps farmers grow more food using less stuff.
Wow, so embedded systems are helping us grow more food with less waste. That's amazing. I'm really starting to see how this technology is everywhere and in everything. But what about the future? What's next for embedded systems? Where is all of this headed?
That's the exciting part. The possibilities are pretty much endless. As we move towards a world where Everything is connected, with billions of devices talking to each other. Embedded systems are going to be leading the charge.
So it's like the Internet of Things, but on steroids.
Exactly. We're talking about homes that know what you need before you do. Wearable devices that keep track of your health 24/7 and can even personalize your treatment. Factories where robots and humans are working side by side, all because of embedded systems.
It sounds like the future is going to be wild. But with all this talk about amazing technology, it's easy to forget that there might be some downsides too.
Are there any ethical things we need to be thinking about as embedded systems become a bigger part of our lives?
That's a super important point. Like any powerful tool, we got to make sure we're using it for good. Things like data privacy, security risks, even bias in algorithms, those are all real concerns that we need to address as embedded systems get more advanced and interconnected.
It's like that saying, with great power comes great responsibility. We have to make sure this technology is used responsibly. Absolutely.
Yeah.
And it's on all of us, the people making the rules, the people creating the technology, and even just regular people using it every day. We all need to understand the risks and work together to make sure embedded systems are used ethically and for the benefit of everyone.
Well said. So, for someone listening who's feeling super pumped about this field, but also maybe a little overwhelmed by how much potential it has, what's the one thing you want them to remember about the future of embedded systems?
I think the most important thing to keep in mind is that this is just the beginning. We're still in the early stages of this tech revolution. The world of embedded systems is always changing, which means there are always new challenges and opportunities popping up.
So, it's not about knowing exactly what's going to happen, it's about being ready to shape the future.
Exactly. If you're the kind of person who loves to solve problems, who gets excited about pushing the limits, and who's passionate about using tech to make a real difference in the world, then the future of embedded systems is yours for the taking.
That's awesome. So to wrap things up, it sounds like a career in embedded systems is about way more than just writing code. It's about creating the future of technology and using your skills to make a real difference.
You got it. It's definitely not always easy, but for those who are willing to put in the work, learn new things, and embrace the unknown, the rewards are huge.
And who knows, maybe one of our listeners will be the one who creates the next big thing in embedded systems, the one that changes everything we thought we knew.
Now that would be something.
That's all the time we have for today. We hope this deep dive into embedded systems has sparked your curiosity, got your imagination going, and maybe even inspired you to check out this amazing field.
Until next time, keep exploring, keep learning, and keep asking what if. That's what drives innovation and helps us break new ground.